Hey there, welcome back to my channel, and in today's video we're fixing your authentication. Most tutorials just stop at basic authentication setup, but that's not how the things actually work. We're going to cover the evolution from basic authentication setup up to the opaque tokens and finally the JSON Web Tokens. Why we use the JSON access and refresh tokens overall. Let's jump right in and see how the things started initially. So in the beginning we had a basic authentication, the Dinosaur setup. How it works? Well, basically the client sends username and password encoded in base64 with every single request. It is simple, sure, but it is dangerous. Base64 encoding is not the encryption. It's just the way of converting a bunch of text into another format. Anyone can decode it. Plus, you cannot actually revoke your token. If you want to lock user out, you have to change this password. Just think about this. You have to change the password of the user to lock him out. This is ridiculous. And this is, of course, not scalable. Let's take a look at the practical example. So I have created the following repository and the following code just as a demonstration example so you could see how the authentication is set up with your own eyes. You can find the link to this repository in the description section below, and I'm also going to leave it in the comment section. So from what you can see here, this is the basic setup. I'm going to use the FastAPI here. What this application does is basically nothing. It just exposes one public endpoint, which returns the timestamp of your request. Now let's see how this kind of thing is going to work in real life. So this is the very basic setup. There is no security. This is just a public endpoint. Whenever you fetch the data, you can see the timestamp is being updated. So this is just a public endpoint, the public API. There are plenty of such APIs out there in the internet, so you can just fetch the data and there is no protection whatsoever. But what if we try to increase the security level and use the basic authentication? So this is the Dinosaur approach that we have just discussed. So all you have to do is just use the pre-existing credentials like basic users and password. I haven't implemented the registration. That's just a basic demonstration of the functionality. So let's try to log in. The credentials are correct and the authentication is successful. Now we can try fetching the new data. And as you can see, all good. We have a successful status here. Hello, basic user. This is protected data. And now the most crucial thing here, what will happen if we try to go to the network settings of our browser and look for this request? So I'm going to fetch this data again. And as you can see, there is a new request in our network tab. And if I go ahead and open this, we can see there is a bunch of different data like access control credentials, access control, content type, blah, blah, blah. But if you scroll down a little bit, you can see the authorization header, which contains the basic authorization here. So what is this one about? So this one is actually our password. And if we try to go to the base64 and decode this password, you can see the real password of the user. So anyone who sniffed the traffic can actually have access to your password. And that's the real vulnerability. If you continue sending those requests and open random one, you can scroll down and see the same basic authorization token, which means it doesn't change across different requests. So you're basically sending your password every time you make a request. And from the code perspective, when a new user is created, you store the user hash, password hash in a database. And then when a user makes a request, you have to take the password that your user is sending to you and then compare the digest of that hash with a plain password. So that's how that works. All right, so we have evolved. We moved to opaque tokens or bearer tokens. The user logs in once and we give him a random string, like Wristband at a club. It's better, but it has a huge bottleneck, the database. Every request, every time the user loads a page, your server asks the database, is this token still valid? Wait for the answer and then proceed. If you have 10,000 users, that's a 10,000 extra database queries. And now let's see how that works in practice. I'm going to the next level. And the next level is medium level of security. I'm going to type here the basic credentials that we already have and log in. And as you can see, authenticated successfully. And here's our active session token. If we try to decode this using base64, we don't have any kind of meaningful value. This is pretty much secure. And one of the great benefits of that is that you can simply revoke the access token. So let's try fetching some result. As you can see, we have the result, we have bearer token authentication type and stuff like this. But if we try to revoke this token and then try to fetch the data again, you can see the data is invalid or expired. After revoking the token and logging the user out, the user cannot access the resource anymore. That's a huge benefit of using the opaque tokens. How does that look from networking perspective? Well, in case if you try to fetch the data, you can see the protected 401 unauthorized request. But if you try to log in again, let me just go ahead and do this again. I'm going to authenticate, and as you can see, there is a login request. And here in our authorization type, we have the payload. And now this is the most interesting part. We have a payload in our request. So in our initial request, when you need to log in, the user actually sends the actual password. It should be encoded, of course, but it is not encrypted. This is why it is very important to use secure connection like HTTPS. On all subsequent requests, you don't have to send password anymore. You just send the opaque token that you have received. So you may be wondering, where do we need to store this token? Well, that's a good question. And there are many solutions on the front-end side where we can actually store this token. It can be in browser state, in memory, local storage, cookies, and stuff like that. But the most secure way of storing them is actually using HTTP-only cookies. That's the way I personally recommend everyone. And from our code code perspective, we can see different requests here, like the options, and we have a get, protected, 200 for one unauthorized, and stuff like this. And here in our code, we can see there are a couple of endpoints like log in, log out, and in the case of log in, we have in-memory tokens dictionary, but in real life, we're going to rely on database. I have just added the dictionary for simplicity purposes. And now enter the JSON Web Tokens. Instead of a random string, the token actually contains the data, the user's ID, their role, some other payload, and when it expires. The server doesn't need to ask the database anything. It just checks the mathematical signature, and it is incredibly fast and stateless. But there is a catch. Because the server doesn't check the database, it also doesn't know if you have banned the user, for example. If I fire an admin, but they have a valid token for the next 24 hours, they are still an admin for 24 hours. We can delete the token because we have never stored it. And the only solution here is to use access and refresh token pattern. So what is the access token? This is the JSON Web Token. It is fast, stateless, and it dies quickly. Well, let's say 15 minutes. Refresh token. Refresh token is the standard opaque token, which is stored in your database. It lives for weeks. When the access token dies, the user sends a refresh token. The server checks the database, giving us a chance to ban them if needed, and then issues a new access token. Best of both worlds. And here how it looks like in practice. Let's say we have a user with a password, and we're trying to log in, and here it is. We have the active session token. If we try to fetch some data, we can see there is a result. And if we try to look for the request, you can see there is a protected request to the server, which contains the bearer token with the following JSON Web Token. You can proceed to the official JSON Web Token debugger. If you try to paste this token here, you can see the expiration date and some other payload here. And also you can see this secret is valid because we're using my secret key. If someone tries to actually tamper our data, this signature verification would be failed. So how does that work? We are using the secret key and the payload to create the signature of our token. Whenever someone intercepts this token and then tampers with data, that means that will inevitably change the payload. And if our payload is changed, whenever our server has to verify the signature of our token, it uses its secret key and this tempered payload to create a new signature. And because this payload is tempered, the signature would be different from the one it received with a JSON Web Token. But you may be wondering why the attacker simply cannot tamper the signature itself, because he doesn't have access to the private key. The private key is being used to create this signature. The attacker is able theoretically to replace the payload with whatever he wants, but he cannot actually tamper the signature because he doesn't have access to the private key. And whenever our server receives the request with the following JSON Web Token, it just recomputes the signature based on the received payload with the signature specified in this token. So whenever you try to use a different secret key, the signature would be obviously different. Here we go. From the code perspective, we have to specify a very secret key and keep it secretly. Never expose this secret key to the GitHub repository or share it with anyone. That should be stored very secretly, like in GitHub Secrets or AWS Secrets Manager or in any other secrets manager. And that's basically it for today's video. I really hope you have found this video helpful. And if you have, feel free to subscribe to this channel to see even more useful videos like this one. Hit the like button, or if you have any comments, please feel free to share them in the comment section below. Also, we have our own Discord community. You can find the link in the comment section below. So if you're stuck with your code, need a review, or just want to show off with your project, feel free to join and hang out with us. And again, thank you for watching my video. See you in the next one. Bye.